Hi, my name is Nguyen Nat, and this is the presentation for Group 2R1-14 about the comprehensive guide to research methodology and effective report writing. Um, we will begin with an introduction to research methodology and all of these aspects, and then moving to the introduction of the selected paper that demonstrate this methodology and report writing, including reading and understanding a research paper, identifying research gaps, and research planning process. Further down, we will also discuss the best practices for presenting results and writing report sections, including introductions and conclusion and other essential parts of writing report. Now, research methodology is the backbone of any study. It's not just about the result, but also about how we arrive at those results. It includes the approaches we choose to gather data, analyzing it, and interpreting the outcomes. By defining this process clearly, we make sure our research is trustworthy, systematic, and can be replicated by others. Now, the core purpose of research methodology is to give direction. Without this direction, a research can become vague or inconsistent. Methodology also helps us with justifying why we choose a certain approach, ensure our work is transparent, and allow others to verify or build on our findings. It also essentially the link between that we want to achieve and how we're going to achieve it. Now, writing also is also as important as doing research. A well-written report doesn't just present findings, but also documents the entire process. This transparency allows others to learn, replicate, or challenge our work. When structure is properly and written with clarity, the report becomes a valuable contribution to the academic and professional community. Now, the chosen paper that's going to demonstrate all this research methodology and report writing will be the variational autoencoders-based self-learning model for tumor identifications and impact analysis from 2D MRI images. This paper addressed one of the most important challenges in medical image analysis, which is accurately detecting and assessing brain tumor using MRI scan. Um, the traditional deep learning models require very large datasets and extensive training time, which is not often feasible in real-world healthcare scenarios where labeled data is scarce. To overcome these limitations, the author of this paper proposed a self-learning network that integrates the variational autoencoders for generative images that mimic the original image, and then also additional to the synthetic training image. Um, they also proposed a long short-term memory networks for returning historical learning and texture-based features extraction for precise humor segmentations. Now, the reason why we selected this paper as the basis for demonstrating research methodology and report writing because it has several core qualities that make it a strong teaching example. First of all, it's clearly defined it has a clear research problem. So it's about the accurate tumor detection with limited data. It also have well-defined objective. So it aims to um, developing a self-learning model using VAE for data augmentation, integrating long source memory, and so on and so forth. It also have comprehensive literature review. So it's complex, classical, and modern segmentation methods, and explain the strengths and weaknesses. The methodology section also provides structured step-by-step process of the progress of creating the model, and the experimental designs of the research is also very clear. It includes all the data sets details, evaluation matrix, and a good and a confusion matrix. the paper also have this balance of technical depth and accessibility. So it is like technical enough to showcase advanced AI methods, but still approachable for student learning research writing. Now, for the first thing that we want to talk about is we talk about reading and understanding a research paper. When we talk about it, it mean more than just scanning the paper. It's an active process where we ask the question, like we can ask all the questions, starting with like what is the paper trying to solve. In this case, about identifying the tumors from MRI scan with limited data, and then we look at the objective, what they promise to deliver, and then next we'll focus on the methodology, what models, algorithm, or experiment they use. Then we check on the results, what the metrics or finding that support the claims, and then finally we review the conclusion, which often connects to the work back of the wider research community. Now let's apply this to the paper that we have. First, the problem will be like brain tumor detection with small data sets. And then the second will be the gap. So most methods can segment tumors, but they don't evaluate the tumor progressions. Now the solution of this paper is like they combine three things. A VAE to generate the synthetic MRS images, and now SDM network to retain the memory of the past segmentation for the tumor progression, and the Harris algorithm for segmentation. Together, this become a self-learning system. And then finally, the result, they achieve like approximately 89.7% accuracy, which is significant given the small data sets. They also analyze the tumor progression, like the tumor core, the whole tumor, and enhanced tumor, which many previous studies didn't do. Um, Now, so why is reading carefully so important? So, as first, it prevents us with misinterpretations. If we skim and assume we understood, we may misinterpret the methods or findings. Second, is beyond the foundation for identifying what's missing or where improvement can be made. Without deep understanding, we can't critique effectively. So, now move on to the next session will be about identify the research gap. When we talk about it is really asking about what has not yet been solved or fully explained in the paper. A research gap is the opportunity for new work. It can be theoretical, methodological, data related, or practical. So we usually find these gaps by reading related literature carefully, seeing where existing model perform poorly, where the datasets are too limited, or where future work is suggested. For example, if most models require huge datasets and small dataset solutions are missing, then there's a gap. Without a clear gap, research may repeat what has already been done. Identifying the gap as well work as something new to the knowledge that has already been established. Um, in this paper, the author identified two specific gaps. First, the existing deep learning model like the ResNet and VGG work well, but only if we have a huge labeled dataset. In medicine, especially for rare conditions, datasets are often small, so that's a practical problem. And the second case is like many segmentation models stop at drawing tumor boundaries. They don't tell us about tumor progression over time, like how the tumor is growing or spreading, and that's an application gap. The author addressed both by introducing a self-learning model, like we says, um, to identify to segment the tumor and then identify the tumor region. By doing so, they fill the gap of the more small data set detection and progression analysis. So the identifying the research gap is one of the most important part of the methodology. It justifies why this study exists. Without a gap, the paper looks like a repetition. The gap also guide methodology. If the issue is data scarcity, then the measure should include data augmentation like VAE. If the issue is like a progression analysis, then the method just include tumor growth tracking. Move on to the next would be research planning. Research planning is like creating a blueprint before building a house. We decide what data to use, which methods to apply, and how success will be measured, like the matrix. Without this step, we risk wasting time for design and result can be trusted. All right, so let's refer to the paper that we showed. So in this paper, the planning was clear. The authors chose the brass dataset, applied pre-processing and removed noises, and built a model combining all the networks like the VIE, the LSTM, and then the Harris algorithm. They also define evaluation metrics early on, which make the result easier to validate. They also clearly define the resources and all the related algorithm that they're going to apply. Um, so the why research planning matters, like planning links objective with matters and result. It ensures the study runs smoothly, is resource efficient, and can be repeated by others. So without planning, the research often becomes scattered and unreliable. With the implementation, research implementation is where we move from the idea on the paper to actual experiments. This means cleaning and preparing data, applying the planned model, and running experiment by step. While following the plan is essential, researchers must also adjust when practical challenges arise. Implementation is crucial because it tests whether the plan works in real life. It helps reveal what parts of the design are strong and where adjustments are needed. In this paper, the implementation followed the planned pipeline. They first cleaned the MIR scan from the dataset, and then they use a BAEs to generate extra training images. The Harris algorithm segmented tumor regions, and LSTM help improve classification by remembering the previous patterns. Finally, they classified the tumor types to analyze the progressions. With the implementation of the research done, then they got the result at hand. Displaying the results is all about the communications. Results should not be hidden in dense text, but presented clearly with visuals like tables for metrics or graph for trends and confusion matrix for classification outcomes. The key is to ensure results connect back to the original objectives, proving whether the research questions were answered. Referring back to the paper, this paper used multiple result displays. The cut graphs showed training and validation performance over each epoch, not each, well, over epochs. A confusion matrix revealed how well the model classified tumor, how and non-tumor tissues. Table also used to compare the proposed model against other networks like VGG and ResNet. They also displayed tumor progression visually, showing tumor core, whole tumor, and enhanced tumor. These displays make the outcome convincing and easy to follow, even for those who has never been reading any similar papers. Now, with the that's all for the research methodology. Now we move to the report writing. So the proposed method section in is the technical core of the paper. Um, it answers the question how exactly did one solve the problem. This includes the design of the model, algorithm, and step-by-step workflow. Importantly, it should provide enough detail so another research could replicate the work independently. Alright, so in this paper, the proposed method is a self-learning network. It begins with preprocessing, followed by a variational autoencoder to generate extra MR images, and then segmentation with the Harris algorithm, locks the memory to help model remember the past classifications, and then finally the softmax layer that makes tumor or non-tumor predictions. They also use the GMCM texture feature for better segmentation. This detailed breakdown allows others to understand and rebuild the system if they want to. Um, and then with the next part will be writing the experimental result. The experimental results section provide the proof of what methods, the proof that the method works. It usually includes numbers like accuracy and sensitivities, graphs to show learning behavior, confusion matrix to highlight the classification quality, and comparison with other models. Importantly, the result must link back to the objective, showing whether the method shows and state the problem clearly. And then with the experimental result part of this paper, it shows that nearly 90% accuracy with strong sensitivity and specificity. The author also in the report displayed the graphs of the learning curves, a confusion matrix, and segmentation map showing tumor progression. They also compared the model with CNN, VGG, and ResNest, showing the self-learning models perform better for small datasets. This even strengthened their scale more. Um, and then with the introduction and conclusion part of the report, the introduction is where the reader decides if the paper is worth continuing. It gives the context, identify the research problem, and state the objective, and show the results of the research as well. The introduction also outlines the contributions, what new and valuable about the study. A well-written introduction grabs the attention and shows the importance of the work. And then the conclusion is not just a summary of the report, it emphasizes the findings, contribution, and impact. It often discusses the limitations and point towards the future direction. A strong conclusion leaves the reader with a lasting impressions of why the research matters. Okay, so um, with the paper, the introduction clearly had the context of like the current work under tumor detection using MRI, and then clearly stated problem with the small data sets and like the progression analysis, and also show the objective of building a model with self-learning model with integration of variational autoencoder and large short-term memory. With the conclusion, it again state the result of the model, and then stating that the model is efficient for small data sets, and then it also include the progression analysis, which adds value to the research, and then also open up the future direction for bidirectional LSTM optimization and the application on the larger data sets. Now, to sum up, these papers demonstrate how research methodology and report writing come together. We start by reading carefully, identifying gaps, planning our report, planning our approach, and then we implement the systematically, display the result clearly, and then write the methods and finding in details. Finally, this strong introduction and conclusion give the paper impact. When followed properly, this process ensures the research is structured, reliable, and valuable to the wider community. And that should be all. Thank you for listening.